is Shinichiro Horikawa, and this is the second episode of VEX for Algorithmic Design. And the topic today is group. When you go to the document page for groups in Houdini's website, it says that the groups are named collections of points or faces, and it is one of the important elements in Houdini when it comes to deal with procedural modeling or algorithmic designs, because by using the groups you can filter out which points to work with or what kind of primitives to deal with specific functions. So in order to do a conditional geometrical operations or more complex geometrical operations, you will need to use groups at some point. So this is the topic that I'm going to show you today. In order to understand groups, let me first draw you some sketch how you can imagine the groups are like. Right, so first of all, say that you have some polygonal geometry like these, made with points, vertices, and faces. The groups can be used to collect some of the faces together and some of the points together to make it as one group. Say if you want to make a primitive group, groups for faces, some of the faces can be inside this red group and some of the faces can be inside this blue group. By using group, you can split the faces into different categories like this, and by doing it you can later on use specific functions like min pos or something like that to work only with a specific faces that has specific groups. So if you want to let this function work only with the red faces, you can actually do that by filtering it using a red. If you want this function to work only with the blue functions, you just need to change this word to blue, and that's all you need to in order to be able to work only on a blue groups. Same for points. You can make a group for points like by collecting the points that you want to make it as a one group and make the other points as another group like this. And those groups are stored as something similar to attributes in VEX. And you can also access those group values, which points is included in which group can be retrieved using some of the VEX functions like an attribute. So this is what I'm going to show you today. To get started, let me show you how those groups values are stored in each geometry's groups for points, primitives, and vertices, and how you can check them through an interface in Houdini. So let's start by creating a geometry node in object network, then get inside, and let's start by creating a simple geometry like sphere. And let's change the primitive type to polygon for now. Right, so currently we have a bunch of points and faces and also vertices. Like we did last time, let's open up the attribute spreadsheet, geometry spreadsheet by clicking this plus button, and you paint type and go under inspectors and geometry spreadsheet, and there you should be able to see the attributes for each point, vertex, and primitives. So in order to store those points or primitives or vertex into some specific groups, there are mainly two ways to do that. One way is to use group node, which is pretty simple, and another way is to use VEX, like point wrangle or primitive wrangle, to store points and groups using a VEX coding. Now I'm going to start by using a simple group node because that's simple to use most of the time. So let's search for a group node. by right-clicking the canvas and check this one. Whilst you have several names named as group, starting with group, basically the name group should be fine. Group create is pretty similar to group itself, so let's create a group node, then connect with a sphere like this, then go to a inspector and see what kind of parameters you can change. Okay, first of all, if you go to the inspector tab for the group nodes, you can first change the type of group by checking this pull down menu. And initially it is set as primitives, but you can also set as points, edge, and vertices. Now the essential groups are primitive, points, and vertices, and edges are a bit special compared to those other three groups. So let me start by going to the primitive. And when you set the group type to primitive, and let's also name this primitive group something prim group, could be anything. And by doing it, as you can see on the display, all the faces has been highlighted as yellow or orange like this. It means that all those faces are stored in this group called prim group for primitives. In order to check if this primitive group has been really stored for each primitives, you go back to the geometry spreadsheet where you use to check the attribute values. And if you go to the primitive tab, you see that a new column has been made named as group colon prim group. And this indicates that each primitive has been stored in a prim group. And you see that the value is stored as 1. 1 means the primitive is actually inside this prim group. And if it's equal to 0, then that means that the group is not inside this prim group. Well, since this is in the geometry spreadsheet, some might think that this is equal to attribute, but it is not actually an attribute. You kind of cannot access to these values through an attribute related functions, but you use another kind of functions in order to access this value. So don't be confused with attributes and groups. These are kind of a special types that you use to filter the geometry. Okay, let's change this to prim group. And let's also try another types of groups. Say, let's create another group for points this time. So create another group node, then go back to the inspector and change the group type to points. And let's name this PT group. And if we go to the geometry spreadsheet again, you no longer see primitive group inside the primitive tab, but when you go to the point tab, you see a newly created column saying group colon PT group. So it's pretty much the same as a primitive group. You are just changing the group type from primitive to point. So the point at this time, each point is stored in this group called PT group. Same for vertices. Let me duplicate this group node and change this to a vertex. Vertices, let's name this BTX group. And you go to the geometry spreadsheet. Inside the vertex tab, you see this group being stored for each vertices. All right, so that's the three essential groups: points, primitives, and vertices. Now, as you can see, there are one more types for groups, and that is for the edges. Now, let's also create another group node and connect to the sphere. And let's name this edge group, and change the group type to edges. Now, for edges, there are no ways to check which edge is stored in specific edge group, because if you go to the geometry spreadsheet, you notice that there are no tab for edges. For the geometry spreadsheet, there's only points, vertex, primitive, or detail. So unfortunately, there is no way to check which edge is stored in which groups. So that makes it a bit hard to deal with these edge groups, but it is also important when you want to do the complex geometry operations using edges. So you still are going to use a lot of these groups later on. But compared to those three essential groups, it is going to be a bit more hard to deal with. Right. So these are the essential group types, 4 different group types that you can use in Houdini. Now that we have some image what group is, what kind of group types are there, and how you can check the groups inside the geometry spreadsheet, let's try to set the groups by using VEX functions instead of using a group node like this. Let's create another sphere geometry, then make it a polygon. Now before getting into how to set a group through a VEX code, I first want to show you how you can set the attribute for each point or primitive or vertex through a VEX code in a different ways compared to the one that I showed you previously. Let's try to create a point attribute using a point wrangle, and let's name this set pt attrib. And in the last video, I showed you how to set an attribute for each point by using an expression like this. If you want to create an integer attribute, you type as I at and then create a name for the attribute like ABC and set the value like this. By writing like this, you can set a integer attribute called ABC as a value 100 to each point. If you go to the geometry spreadsheet, you can see that all the points have the value integer 100 as named as ABC. Now if you go to the document page for VEX functions, you can go to this page by searching Houdini VEX functions. You will be able to see some more flexible functions in order to set an attribute to specific point, and that is called set point attribute if the geometry type is point that you're trying to set an attribute. If you go there, this is the description page or description document page, how you can use this function called set point attribute and have some parameters like shown like this, closed with this parenthesis. And this first geo handle is the input number of the point wrangle, which is equal to the number of these input point. So the first one will be 0, second one will be 1, third one will be 2, and fourth one will be 3. So most of the time you will use 0 for geo handle. The name is the name of the attribute that you want to set as. So in this case, I am setting a name for the attribute as ABC, so you can set this name parameter as ABC. The point num is the point number that you want to set the attribute to, which is equal to this left-hand column values, which is equal to a point number for each point. And in order to access each point number for each point, if you could remember, we were using a value pt num, which is the special parameter or special attribute for which you can use only in the point wrangle to access each point ID or each point number. So if you want to set the attribute to all the points through a point wrangle, you can set pt num here. And last of all, the value is the actual value that you want to set to this specific attribute, and in this case you can set it as 100, right? And the last one is an optional parameter. The default value is set, which means you can override the attribute to this specific attribute. But there are more options for this mode. If you set it to add, you can create a new attribute if there's no attribute already being created, or you have more valid options like this. But for these, it's a bit more advanced, so I'm going to explain in another videos. Right, so to replace this function or replace this expression with the function that we have just seen, you write like this: set point attrib. The name of the attribute is ABC, and we want to store in every point number through a point wrangle, so we use ptnum. So if if this operation is looking at the point number 0, then this will be 0. Then if the point number is looking at the point number 1, then this will be 1. And it is being called simultaneously or in parallel for each point. Then last of all, you set the value that you want to set as an attribute, this ABC attribute. So let's comment this out by typing // This 2/ means you want to deactivate the code that is written on the right hand side. So by doing it, you can ignore this coding and just activate this one. Right, so let's go back to the geometry spreadsheet, and you see exactly the same results. So that's how you can set an attribute through a special functions called set point attribute. The reason why we use this set point attribute instead of using this simple expression is because sometimes we want to make it set the attribute in more flexible ways, especially when you want to change the third parameters for this set point attribute, which is the actual point number, which point number to set the attribute to. Actually, this I at ABC equal 100 is equal to this one, and this expression only works when you want to deal with all the points through a point wrangle. So that means that we are dealing with each point number in the point list. But if we just want to set an attribute to the first point attribute, then we type like this, like 0 instead of ptnum. And in this case, if you go back to the geometry spreadsheet, you only have 100 value to the first point listed inside a point list. And you cannot do something like this through this expression because this expression only works for every points. And in order to limit the value, limit the points, which points to set an attribute to, you kind of have to use set point attribute instead of this expression. So that's the reason. And in order to set a point group or primitive group to specific primitive or points, you use similar functions looking like this set point attribute. So let me show you now how you can set a groups for each point or primitive using a function like this. And unfortunately, there are no simple equations or simple expressions to set a group like this. This is only for the attributes. In order to set groups for each point, we're going to use another point wrangle. And let's connect this to a sphere again. In this case, say set pt group, right? Then this time we're going to use a special functions in order to set the group, and that group, that function name is called as set point group. We use this a lot, so please try to remember this function name. Okay, so let's first look at the document, what kind of parameter we have to input in order to use this function. So the first parameter for this function inside this parenthesis is geohandle, which is similar to the set point attribute. So this was the number of the input. Basically, this will be 0 for set point groups. And the name is the name of the group that you want to set as. The point num, it is the point number or point ID, which point to set the groups to. And finally, the value. And the value for the groups will be either 0 or 1, as you have seen through this set group node. So the value that you have to type here is either 0 or 1. If it's 0, then that means that the point is not inside the group. If you set it as 1, then that means you are setting that point inside the specific group that you set here. Okay, and there's also a mode similar to a set point attribute, but we will going to ignore for this in this video. So we're only going to deal with these 4 parameters. Okay, let's try this out. Enable the point wrangle right here, and then say set point group. And the first parameter is the geometry handle, which is the number of input. So it's connected to the first input, so it's 0. And then give a name of the group, let's say PT group. And the third parameter is the number of points, which points to store the groups to. So if you want to store in every point, we use ptnum. Then finally, if we want to store it inside a group, then we set as 1. If you want to remove the points from the group, then we set it to 0, right? So let's say we want to store it inside this ptnum, inside this pt group. We go back to the geometry spreadsheet and go to the point tub and check that each point has been stored in a group called pt group. And it seems like it has been successfully being stored inside this point wrangle or point group. Now there are some time that you want to remove the point from specific groups. So in that case, we just set this value to 0. So say we already have some points that are stored in a group called PT group. Then we want to at some point remove all those points from this group by doing some operations. We're going to create another point wrangle below underneath this set point group. It's named as remove PT group. And in order to remove this, we do pretty similar things that we have just done here using set point group. But instead of setting as 1, we're going to set it as 0. So set point group, the name was PT group, and if we want to deal with all the points, use at ptnum and set it as 0. Then if you go back to the point wrangle, you see that you still have the PT group column, but all the values for this column for every point is turned into 0, which means the point is no longer inside this PT group. And the good thing about using this function is that you can specifically set or unset the group by determining which point ID you want to specify or unset or set. So if you just want to unset the group for point number 0, then you type it like this instead of at ptnum. And then if you go back to the geometry spreadsheet, only the first point has been excluded from the PT group, and all the other points are still inside the PT group like this. So by mastering how you can deal with this third parameter for the set point group, also for set point attribute, you can kind of create a really complex conditional geometry operations. Okay, well, I'm going to reset as ptnum for now. All right, so that's the basics, how you can set a point group or remove the point from a specific group. And basically, if you want to do the same operations for a primitive or vertex, it's pretty much the same, just that the name of this function is a bit different. If it's primitive, the name of this function will be set prim group. If it's vertices, it's going to be set vertex group. And you can check that by going back to the VEX function. And if it's primitive, it's set prim group. And if it's vertex, it's set vertex group. And the parameter itself is basically the same with set point group, and just that you have to notice that this prim number is not the point based number, but it should be the primitive related number. So let's duplicate this and say set prim num or prim group. What you just need to do in order to set it as a primitive group, set inside a prim group, you just change this name of the function to set prim group and change the group name to something like prim group, could be any name. And we also have to change the run over to primitive because we want to deal with all the primitive values. And inside the primitive type, in primitive run over, we cannot use ptnum because this is a point specific attribute. So in order to access the primitive number we use like this. We use this special attribute called primnum. And by doing it, you can kind of get a similar results, like the points go back to the geometry tab, and you see that primitive related group has been created, and all the primitive has been stored in this group called the prim group. That's how you can set the group through a VEX function. Now, once we have set a group, next thing we want to do is to actually access to those group values through a VEX code, so that we can use it to filter out the operations. So let's try to do that through a VEX coding. Okay, so let's create a sphere. And this time I'm going to create several geometries. First, a sphere, set it as polygon, and I'm going to create another geometry like box and move it a bit to the right. And let's also create another primitive like torus. Let's also move it to the right by changing the x coordinate. Okay, like this, and let's merge them together so that we can see all those geometry in one place, like this. Now, what I want to do here is to set groups for each geometry, and maybe for the last one, for the torus, we don't want to set any group in order to differentiate the conditions. So for the first geometry, I'm just gonna use the group node to make it simple, and I'm gonna set it as primitive group and named as sphere. So if you go to this geometry spreadsheet, all the faces have a group called sphere. And for the box, I'm going to create another group node and name as a box. So these one, if you go to the primitive tab for the geometry spreadsheet, you have a column called group box. Now for the torus, I'm not going to attach any group node. And then merge it together, and if you go back to the geometry spreadsheet, you see two columns being created for a primitive. One is for the box, one is for the sphere. And you can see that some of the primitive has a group called sphere, and some of the primitive faces have a group called box, and some of the primitives are not stored in any of the primitive group box or sphere, which you can determine by checking the value for each rows. So if it's 0, it means that the geometry or primitive is not stored in that specific group. If it's equal to 1, then that primitive is stored in this specific group. So these 1, 2, 3, 4, 5, 6 faces are stored in a group called box, and other one is stored in sphere, like this. The reason why I have made this kind of condition is to try out using a VEX code to filter out some groups. Alright, so let's create a primitive wrangle in order to access to a specific group objects. Okay, I'm gonna name this axis group. Go back to the inspector, code editor, and the first thing we want to get is the geometry which is inside the box group, and should be these faces. So for the box we have 6 faces, so we want to get those 6 specific faces that should be inside the box group. So in order to retrieve the value whether the box is inside the specific group or not, the function that we're going to use is called imprim group. If it's point, it's in point group. If it's vertex, it's in vertex group. In this case, we're dealing with the primitive group, so we're going to use this imprim group. The other functions, in point group and in vertex group, is pretty similar to this one, the parameter wise. Okay, so let's look at the parameter, what kind of parameter we have to input in order to use this function. So the first input is a geometry handle. Again, this is the number of inputs. Could be if the value is connected to, if the node is connected to the first input, this will be 0. The geometry handle is 0. If it's connected to this one, then it will be 1, 2, and 3. So basically, this is going to be 0 since right now I'm connecting to the first input. And go back to the second parameter. It is the name of the group. So in this case, we want to access the name called box. So we type box here. The primnum is the primitive number, which primitive to check whether it is inside a box group or not. So if you are using it inside a primitive wrangle, and if you want to check all the primitives, then like we did for set primitive attribute or set point attribute or set point group, we use at primnum if it's primitive. If it's point, then it's at ptnum. Okay, so in this case, we're going to use imprim group, and we are checking at the first input. Then the name of the group is called vox. Then the third parameter is the number of primitives, so at primnum. Now, just writing like this doesn't really make any sense, because we kind of have to retrieve the value which is equal to these values for each primitive. So you kind of have to get an output of this function. And if you go back to the function page again, it says the return value is something, and it says 1 if the group exists and the primitive is in the group, or 0 otherwise. So the output of this function is actually an integer. It is also shown here, and it is going to be either 0 or 1. And if you get the value 0, then that means that specific primitive number is not inside the box that you have specified here as a box name, group name. If it's equal to 1, then that means that primitive is actually inside the group that you have specified right here. So in order to determine whether this is 0 or 1, let's try to set this output value as an attribute to each primitive. So in order to do that, we're going to use the simple expression like we did last video, like I at in box. So we are creating an integer attribute called inbox and assigning this output to that specific attribute like this. So let's go back to the primitive wrangle, primitive geometry spreadsheet again. And then you see that you have just created a value called inbox. And if you go down a bit, you see that some of the primitive value has a value called 1, and that happens only when the group is equal to box. So this means that we have just transferred this value to this inbox as it is. So it's not that interesting likewise, but this is actually a integer value. So if you multiply this by 50, you can kind of get a multiplied value like this and stored in an inbox attribute. Right. So let's try to do the same for a sphere. So in sphere, we're going to check imprim group sphere primnum. This time let's try to multiply it by 100. Go back and see, and you see that some of the primitive has a value called in sphere equal to 100, and that is only when the groups is set as sphere equal to 1 like this. And all the others like torus, since it is not stored in neither box or sphere, both the inbox and in-sphere value is equal to 0. So that's kind of an essential way how you can access to the whether each primitive is stored in specific group. And you can do the same for point or vertex by changing this function name and changing this to point specific value or vertex specific value. Now in this video I'm just going to show you the really basics of groups, setting, accessing, and so on. And in order to use them for procedural modeling, you kind of need to combine this group operations together with a more a complex programming technique like if conditions, for loop, dealing with arrays or string or variable. And for those complex operations, I'm gonna show you in different videos. Okay, next let me show you another kind of functions for group, and this time let's try to use a function to check how many primitives are stored inside a specific group. For example, how many primitives you have inside this box group, or how many primitives you have inside this sphere group. So basically for the box you only have 6 faces, so if you try to the result should be equal to 6 if you want to check the number of faces or primitives which is inside this group box. And there are functions you can retrieve that kind of information, and let's try to use that for primitive. I'm going to set a primitive wrangle, and I'm going to name this number of prims in group. And let's go back to the function page for the VEX, and let's check the actual function name in order to retrieve the number of primitives which is inside a specific group, and that is called an primitives group. Alright, if you check this out, so we have 2 parameters. One is the input number, second one is the actual group name, so pretty simple to use. And the result is the integer value, which is the total number of primitives which is inside this group name. Okay, so check this out, and I am going to store the result to a primitive attribute again. I'm gonna say set it as num faces, and this time I kind of don't need to do this inside a primitive run over. I can just calculate the number of primitives just once, so maybe I could do this through the detail. So I'm going to create a detail attribute called num faces, then access to a number of primitive by using an primitives group. And the first, since the connection is set to a first input, so it is equal to 0. And the second parameter was the name of the group, so let's set it to box. Right. So the result should be equal to 6, and let's check that out going to the geometry spreadsheet to the detail attribute, and as you can see the value 6 has been stored in a name faces attribute for the detail. And that was the number of faces which is stored inside a box primitive which is inside a box groups. If I change this to sphere, then the result will be 80, so it means that there are 80 faces for the sphere group, which should be equal to the number of faces for this sphere geometry. So that's how you can access to the number of faces inside a specific group. And sometimes you want to access the actual primitive number, which primitive number is actually inside a group called box, or which primitive number is actually stored in a sphere group. To check that, there is another function called expand prim group. Let's go back to the VEX function page, then search for expand prim group. And you also have expand point group, expand vertex group. I think there should also be an expand edge group as well. Now if you go to the expand prim group, the number of parameters is the same as n primitive group, but the result is a bit different, and it is an array of integers. Now we haven't talked about the array that much, but it is a list of a specific value, in this case a list of integers, which means you have a box and you have a bunch of integer values inside that box. And this function gives you a result as a list of integer, and that list of integer indicates the actual primitive number which is actually inside this group that you have specified. So if the box primitive is stored, if the primitive number 0 to 5 is stored inside the box group, and if you have used this function for box group, then what you get as a result is 1, 2, 3, 4, 5 through this function, which is convenient if you want to access all the primitive number, point number, or vertex number for specific groups. And you use a lot when it comes to deal with the complex geometry. Same for accessing the group and get the number of primitives in group. Okay, so let's try to use this. Primitive wrangle connected here. And let's name this get prim nums in group. Okay, so I am going to create a array attribute called prims for each primitive, or maybe to detail as could be fine, should be fine. So I have just created a integer array attribute called prims. If you want to deal with arrays, we type like this, I with a square bracket. Then use at, then we specify the name of the attribute, then equal to expand prim group. So the first parameter was the number of input, then the second parameter is the number of box, the name of the box, name of the group. Okay, as a result, going back to the geometry spreadsheet to the detail, you see if the group is equal to box, then we have 6 values stored as an array, and those 80 to 85 are the actual primitive number, which indicates the number of face stored in a group called box. So let's check that out by enabling the face number by checking this icon here, right here. You see that all faces, if you check all the faces numbers, it is actually equal to these 80 to 85 numbers. So we have successfully retrieved those information through a VEX code, which is inside the box group. If we change this to a sphere instead of box, then the value that we will get will be the value which is equal to the primitive number which is on this sphere faces, primitive number for each primitive faces for this sphere group, sphere geometry, which we have set it as right here. Okay, so that's how you can use this expand prim group, and that can be used for point and vertex as well if you change the function name to expand point group or expand vertex group. Now those are the most used group related functions, so please try to remember it, but we're also going to use them a lot in later videos as well. So next we're going to actually use those group values in order to filter out some of the functions to work with. Okay, so first we're going to create another basic geometry setup. I'm just going to copy those sphere and box with the group to the right side by typing Alt drag or Option drag on Mac. And this time I'm going to set the group as point group. So go to the group node and change the group type to points for sphere and points for a box. Then merge them together. And then go back to the geometry spreadsheet to check on the point tab and to check you have two group types, box and sphere. Now I am going to use one simple VEX functions that can be used with a filtered group. I'm right now inside the VEX functions list page, and then the function that I'm going to use now is called near point. If you check the function out, what it actually does, it says it returns the number of closest point on the geometry. This only search against points on the surface location of geometry. So this is the function in order to search for the closest point from the specific point position. And we're going to use this near point function and together with the point group filtering. And in order to use the point group filtering, we kind of have to check the parameter set if we could really use this point group. And for this near point function, in total we have 4 types of parameter set with the same function name, but the last 2 parameter set actually gives you an option to set a point group, to use the point group name, which is this PT group right here. And the third one seems to be simpler than the fourth one, so we're going to use this third parameter set. And if we look at the parameter carefully, we have 3 parameters. The first one is a geometry, which is equal to a number of index of a input. So if it's 0, we're searching to a first input geometry. If it's 1, then we're searching to a second input geometries. The second parameter PT group is the actual point group name that we're going to use it as a filter to search the group for. And the PT, the last parameter PT, is the point position. So we're going to search for the PT number, point number, which is closest to this point position. But with this point group filtering option on, we are only going to search for the points which is only inside this point group. So we you can say that we have 2 search criteria. One is closest to this point position, and one is also inside this point group. By using it, we can do something like search for the closest point to this PT, but is also inside the box group or also inside the sphere group, and so on. Okay, so let's use this. Go back to the canvas, and then I am going to use the point wrangle, and I am going to also create a add node to create a single point which will be used to search for the closest point to this point. So let's go to the inspector of the add node, check this box, and currently the point has been created on the center, onto the origin, when the x, y, and z coordinate is equal to 0. So I want to search for the closest point to this point that I've created through the add node from this geometry set. So if you think it normally, the closest point to this center point should be somewhere that is and belongs to this sphere. But what if we want to search for the closest point which only belongs to the box node? Then we have to use the filtering, and that's when we want to use the group. Okay, so let's connect the add node to the first input of point wrangle and the set of geometry sphere and box to the second input. And I'm going to name this to near point, right? Or maybe group filtering. Okay, and the function that I want to use is near point, right? And for the first input, we have to set the number of input. And in this case, there are two inputs right here, 0 or 1, right? And which one should I choose? In this case, we want to search for all the points which is creating a box and sphere geometry, and that is coming from the second input. So if you're searching to those points that is creating a box or sphere, we're going to set it as 1, which means second input, right? And the second parameter was the name of the group, which group to look for when it comes to searching, when it comes to filtering the search. And if we only want to look into the box group, then we got just going to name this box. And for the box group, we have a point group named as box here. If you want to search for the sphere, then you use sphere instead of box. But currently, let's say we want to search only on the box. Okay, and the last value is the actual point position that we're going to search with, and that is equal to the point position of this add value. And if from here we only have one point value, and if you go to the geometry spreadsheet, it is stored in capital P, which is equal to X, Y, and Z. So we can, since we are in the point attribute or point wrangle for the ran over, we can access to those point position just by typing at capital P. Okay, so as a result, you should be able to get the number of a point, which is the closest point number, which is closest to this 000 value point. And let's check that out by storing the result to a point attribute like this. So integer attribute named as npt. Okay, so going back to the geometry spreadsheet, on the point tab, you see a newly created column named as npt, and the value says 42. And let's check where that 42 number is actually inside this from this geometries. So let's show up the number of points. Then let's also scale the text up a little bit by going to the visual guides, set the guide fonts to large. Now it's a bit more easy to see. Now the number we will want to check is 42, and you see that the 42 right here, point here, and this is actually the closest point from the center, and that is also belongs to the box group. So we are kind of ignoring the sphere geometry, but only looking at the box group. And let's try to change the position of this center point to the left, and see, maybe to the far left, and let's look at the changes. And it says now the closest point to this specific point that we have just moved is equal to 43, and that is equal to right here. That is understandable. But if we move this a little bit to the z direction, then the value changes to 44, which is equal to this point. Now, if we change the group name to sphere instead of box, what would happen? Now, if we look at the detail point attribute again, the value has been changed. The NPT has been changed to 27, and that 27 is no longer belongs to the box group, but it actually is a number somewhere inside this sphere, and that is somewhere right here, this point. So even though the point is really close to the box, since we used group filtering to search for only the groups that is named as sphere, so we're only searching for this one. Then from this sphere, we're searching for the closest point to this point, and that was 27, which is this point. So this is one of the simple example how you can use a group to filter out the operation, the function, geometrical operations. And near point is one of the most used functions dealing with the groups to filter out. And there are a lot more with this kind of group operation, group filtering, and I think in the later videos I'm going to show you more examples. But remember that you can do something like this. Another way to filter out the group is by using this parameter in this channel inside a wrangle node right here. And you see the name of the parameter named as group, and I think you have seen this parameter for other kind of node as well. Something like transform. You also have a parameter called group, and all the other geometry related nodes use, most of the time you see this groups have group channel as well, and those channel can be used to filter out the geometry, what kind of geometry to operate with. So let's also try to use this as well. Maybe you already know that, but just in case. And this also works for VEX functions as well. So let's create a point wrangle, and I'm gonna name this move with group filtering. And what I want to do is to only move the box geometries to the z direction by using this group filtering. So right now the run over is set to point, and if you click this pull down menu, you see the list of point groups that are set for the first input, from the first input, and you have currently have two group values, either box or sphere. And if you only want to work with the points which is inside the box group, then you say group box. Then the box string has been typed inside this channel, and by doing it, whatever code you write here only works on the box group geometries. So let's type some code to move the points like we did last video. Point at P, this is the point position, and move this to a z direction by creating a new vector like this, set 0, 0, 1, so moving to the z=1 direction together with the current point position. And as you can see, only the geometry which is inside the box group has been moved to the z direction like this. If we change this group to sphere, then this time only the one that is inside the sphere node, a sphere group, has been moved. If we delete this group, then all the geometry is going to move on a z direction. So this is maybe the most simplest way to use a group to filter out the operations, right? And if you want to do more complex operations based on a group, then we can either use this kind of group filtering together with using this access group functions to retrieve the value 1 or 0 and then use them with kind of a conditional operations like if conditions. And I am going to talk you about the if conditions later on other videos, so don't worry about that. But the simplest way, you can just type in the groups right here. Now, last thing I want to show you about the group is group expressions. Currently, we are just using a group as a constant value like this, but actually you can type in more complex filtering expressions instead of just typing a name of the group right here. So instead of using a constant value like a box or sphere, which you can check inside a geometry spreadsheet as an attribute, you can kind of create your own custom conditions inside this group channel, and that is called as group expression. And I would like to talk to you about this in a basic manner. So let's create a geometry like sphere again, set it to polygon, and let's create a point wrangle. And I'm gonna name this group expression 1 like this. And what I want to do is to move some of the points using a simple VEX code, like I just did, using maybe move the point, all the point to a x direction with a value of 1. In this case, currently I have one geometry like this, and then moving all the points to the x direction by 1 using this VEX code. Now I want to filter out kind of points that I want to move from the basic setup like here. So let's say I want to move only the points which the x coordinate of current point value is larger than 0. So there are some values which is smaller than 0. The left hand points are the one that has negative x coordinate, and the right hand points are the one that has positive x coordinate. And let's say I want to only move the point which the point x coordinate is larger than 0. So how do we do that? Using a group expressions. And I just want to type the conditions right here inside this group channel. To do that, we can first go to a page for the groups, and that is inside the Houdini document, under the Houdini document, under the geometry, and there is a page called groups. In this page, it shows some expressions reference how you can make your own conditions. Now it looks a bit complex if you look at this document. There are some patterns, expression patterns that you might not understand on the first look, but I am just going to deal with the simple operations. Now there are basic patterns you want to remember. One is this asterisk pattern, which will be used to match all the geometry inside without any filtering. And if you add this exclamation mark before the asterisk, it means that to exclude all the geometries. So meanings there is going to be no match, which I don't think you use that much. And this group name pattern is equal to using the name of the group like we used right here. So by setting a name of the group like box, you're filtering the search only to the one that has a box group name. Now what we use a lot as an expression instead of this group name is maybe this one as well, the n pattern n. N is equal to a integer value, which is equal to a point number, primitive number, or vertex number, depending on the ran over right here. If it's equal to point, then the integer value written right here, meaning the point number that you want to operate on. So if you type 0, then only the point number 0 will be used to deal with this code. So if you type 0, you see that only the point 0 has been moved to the right side. And if you want to include more point number, like from 0 to 5, you type like this, 0-5. Then the point that is within the 0 to 5 is going to move to the right side. All those points within this condition will be used to operate this function. And if you want to concatenate the conditions, like you want to work on point 0 and point 4, you add the condition together with a space in between the conditions. So if you want to work on only the point on 0 and 4, then you type 0 space 4 like this. You can also do like this as well if you want to work on 0 and between 4 to 5, do like this. Another kind of group expression that you want to remember is using an attribute value like this pattern. And in order to use that in a group channel, you type like this, add some attribute name, and use that with the condition. Currently, if I want to deal with the x coordinate of the point position, then we want to access the x element of this at p vector value. So if you go back to the point wrangle or point geometry spreadsheet, we have an attribute called capital P, which has x, y, and z value. And they are corresponding to the x, y, and z coordinate of the point position. And if we just want to access to this x value right here, then we type like at p dot x. And this itself doesn't make any meaning because it's not related to any conditions, but we can combine this value together with an operator like smaller than, larger than, or equal to, or not equal to operations, and to make a conditions. So if you want to make a condition that the x coordinate is larger than 0, then we type like this. And by doing it, all the points that is on the positive coordinate x coordinate will be used with this for this function. And you can do the other kind of operations. If the point x coordinate is negative, then move the point to the right side, or by setting it to negative, you can also move it to the left side, to the negative x direction, like this. So it's pretty handy when it comes to use the attribute as a group expressions, group conditions, and you want to remember this. In some cases, it's pretty handy to do make something like this. And instead of using a group expression inside this group channel, you can also use this group expression inside the VEX code as well, just like we just did right here. So let's also try to do that, and let's end this session in this tutorial for the group, basic of group. Now we're going to create another point wrangle, name this group expression 2. And this time, I am not going to set any condition inside this group channel, but instead I'm going to write a code. I'm going to write an expression inside this VEX expression, the VEX code. Right. So to do that, first of all, I'm going to create a code to move the point position to the right side, like we did right here. So currently all the point has been moved to the right side. Now what we want to do is to create a condition so that only the point on the right hand side, or on the positive coordinate for the x, should be moved. with this function. To do that, we can access to a group value like we did somewhere around here using access group, using imprim group or impoint group function together with a group name right here. But instead of setting a constant group name, we can actually set a group expression instead of just typing a box or sphere. So let's try to do that. Okay, so since we are dealing with the point, we're going to use in point group, right? And then we're going to look at the first input because there's only one input right here on the first one. And the name of the group is, currently we are not setting this point to any constant group, but in this case right here we want to use attribute as a group expression. So what we did right here, it was at p.x larger than 0, and we can just cut and paste it right here just like this, just the same expression like we write it at here, but paste it at this second parameter for in point group. Then the third parameter was the number of points, which point to look at. So in this case, if we want to look at all the points, then we say pt num, right? So the result of this function should be either 1 or 0. If the point meet with this condition at p.x is more than 0, meaning if the x coordinate is positive, then you should be able to get 1 out of this function. If it doesn't meet with this condition right here, group expression right here, then the value that you get out of this in point group is equal to 0. So that means we can just use this value directly for the x coordinate value right here instead of just setting to 1. So if the x is coordinate, that point x is positive, this should be 1. If x coordinate is negative, this should be 0. And as a result, you will be able to get the similar result that you have got it right here with the same expression typed in. So the result of this one, is exactly the same, just that the group expression has been written inside the group tab, a group channel for this tab, for this wrangle, and for this wrangle, the group expression has been written inside the VEX code. And most of the time I think it's okay to type in the inside the group channel, which is much simpler than writing like this. But at some cases, if you want to do more complex operations using the VEX, sometimes you want to do inside the VEX as well, because the benefits of creating a group expression inside the VEX is that you can kind of programmatically create this string using a programming code. So, and you cannot actually do that for this channel, but if it's inside the VEX code, you can programmatically create this string based on like a ptnum or more conditional way based on some other variables or other attributes. So if you want to do more flexible filtering, then sometimes create an expression inside of VEX is a good idea, and that you also want to remember in terms of when it comes to creating a more complex procedural modeling. Okay, so that is all for the basic of group operations, and we haven't really gotten into the advanced usage, how we could really use this group in real practice, but we're going to do that in later videos. But first, I would like to just show you the basics of each important elements of Houdini before getting into the real advanced operations, so that we could have more deep understanding when it comes to do more complex stuff. Right. So that is it. Thank you very much for watching it. For the next topic, I would like to focus on the channels and parameters for the wrangles, which is similar to this kind of group channel, but you can actually add your own parameters underneath right here as your own controller UI. So would like to talk about that in the next episode, and how you can use them with the VEX code. And that will be the topic for next video. Okay, so thank you very much, and hope to see you next time again. Goodbye. And if you have found this video interesting, please try to subscribe. Thank you.